when I deliver. So learning has to be a joyful experience. Enjoy the module. Thank you. Welcome to the man B&W Camshaft Less engine, electronic engine, ME-C engine. Here, module 3, we will discuss hydraulic power supply. Hydraulic power supply, because the actuation of the FOPB, exhaust valve, cylinder lubrication is all carried out by hydraulic pressure, not by the mechanical force as was in the conventional engine, because there no cam, no camshaft, no drive shaft, no nothing. So naturally hydraulic pressure is used. All right. So double wall pipes are leakage sensor, as I was telling you. A cancelable slowdown and shutdown occurs in case leakage persists for more than a given time. A method of detecting leakage between which two SCU has occurred is also given in the shipboard manual. Of course, each unit has its own SCU. This is also interesting. You must read about this, how to find out where the leakage has occurred, which two HCU leakage has occurred. There is a method available, because all HCU have arrangement, valves and all, so you can regulate the valves, close the valve. Of course, you can do it only in the port. Stop the engine, run the hydraulic pump, engine motor driven, and then you carry out the test. Close this valve one, close the valve in the end, and then put the pressure gauge. All these points are available where you can fit the pressure gauge and all. Then you can check the parameter and continue. There's a method. If I got time, I will also explain to you, but this is not for ME engine. This is a general guidance any engineer will know. So you can be found out. All right. So this is actually, remember module 1 we had discussed. I showed you the picture. This is of course FOPB. This is of course exhaust valve actuator. This is your fuel valve, isn't it? Correct? FOPB, exhaust valve actuator, fuel valve. This is your distribution block, and this is your cylinder lubricator for double wall casing pipe, where the sensors are fitted. This is for cylinder lubricator. Fuel, as per the working of the fuel valve, fuel injection will occur, or your exhaust valve will open. Right? And this distribution block has a valves and all, can be closed, open. Normally, as I said, 300 bar is maintained, but you go and see on your ship, certain ship are still maintaining 250, but depend. As stated above, there is one SCU for each cylinder, one SCU, and each SCU has fuel pressure booster, exhaust valve actuator, fuel valve, and alpha lubricator for cylinder lubrication. This hydraulic pressure is available to fuel valve for operation of FOPB and exhaust valve actuator, and also to operate alpha lubricator for cylinder lubrication. Okay. Now we will see how the engine-driven pump continue to deliver hydraulic oil to discharge port, even when the direction of rotation change from ahead to stern. Okay, now we'll see number 3 unit. Number 3 video. So this is your variable delivery axial piston pump. All right. So this is the housing. These are the pistons. There is the stationary plate. Of course, having suction and discharge port. Actually, all the pistons are at the center. That means moving in one plane, no suction and no discharge, no delivery is taking place, isn't it? When all the pistons rotating in a perfect alignment, in the center line, all are exactly the same way. These are the pistons, and all are in the same direction, not move tilted. Okay. So then what is happening? All are moving in a one plane. So neither no piston is pumping or taking suction, and no delivery. So no discharge, no delivery, no suction. Nothing is happening. Pump is running. Let us say this is the arrangement. This we call hanger or swash plate. Where this side is a stationary plate, upside. Bottom side is the swash plate or the hanger, yoke hanger, we call it. Now the pistons are resting on them. When the yoke hanger is horizontal, all the pistons are just rotating, hmm, and cannot take suction, cannot discharge. No suction, no discharge. But when the yoke hanger is at an angle, now the some piston will be down, and as the yoke hanger rotates, the piston will start going up, going up, going up. And then it will start coming down, coming down, coming down, coming down. BDC, going up, TDC. BDC, going up, TDC. For the pump. BDC, TDC is for the pump, nothing to do with main engine. So when they are down, suction. When it's going up, it's delivering. Correct? So when the directional rotation changes, so let us see this head direction. So in this case, piston coming down, oil is going up. Piston coming down, oil is going up. When the directional rotation changes, angular swash plate must change. Suppose now directional rotation is reverse. Suppose this was discharge port, this is suction port. Now directional rotation is reverse. What will happen? Because now this piston which was coming down will start going up. So actually it will start delivering. Correct? No? So the suction port will become discharge port. But now see what happens if we change the angle of this swash plate. So this piston which was down actually goes up. Isn't it? Let us see. The piston which will go down now is going up. So what happens now? Now the direction rotation is reverse. So the same side which was suction will remain suction. Side which was discharge will remain discharge. So now what will happen? This will come down, come down, come down, come down. 1, 2, 3, going left to right, right, and when then will start going up, it will start delivering. So direction rotation is reverse. But by changing the swash plate angle, we have kept the suction and discharge port same. I have got a video, will show a video. All right. I hope this video is being prepared. Uh, all right, because we prepare ourselves. We don't want to use any other video. I hope will be done. All right. Isn't it beauty? So hydraulic pumps are controlled by the ACU, auxiliary control units. Yoke hanger or swash plate angle is changed by the ACU. It is the responsibility on the basis of the signal of the auxiliary control unit, which changes the angle of the swash plate or the yoke hanger when the direction of rotation changes. All right. So let us take the example where we have 5 engine driven pump. 5 engine driven pump. So if you have the drawing, you remember I've shown you the drawing which we had a 5 engine driven pump. In the module 2, pump 1, 2, 3 are controlled by the ACU 1, 2, 3. Hydraulic pump 4 and 5 are controlled by ECU, engine control unit. Remember A and B. So hydraulic oil pressure, depending upon the engine load, is controlled by pump number 1, 2, and 3. Because pumps driven or controlled by ECU A and B will always kept running in the maximum possible capacity, as if engine is running in that direction. Roughly it is 85%, they say. So any one of the pump can be chosen and selected to run in the control mode. So one of the 3 pumps controlled by the auxiliary control unit, ACU, is chosen as controlling pump. What is the controlling pump does? Controlling pump will run at the 50% of the capacity. So auxiliary control unit of the pump which has been selected as controlling pump will make sure its capacity is 50% by changing the angle of the swash plate. By changing of the swash plate angle, not only you keep the same suction and discharge port when direction rotation is reversed, you can also control the capacity of the pump, isn't it? Because when swash plate is 100 exactly horizontal, no delivery. Angle changes little bit, 1 degree, some delivery, 2, some more, 3, some more, 5, some more, 6, some more. Total 15-degree maximum tilt is allowed, is permitted, is possible. So hydraulic pump, which we have designated as controlling pump, what will do? It will keep the capacity of the pump by 50%. For any pump which managed controlled by HCU 1 or 2 or 3 can be a controlling pump. Remaining 2 pump will become follow-up pump automatically, but they'll become follow-up pump. Swash plate of the controlling pump will be kept at 50% position. The follow-up pumps swash plate position will be from 10 to 100% as required to maintain the hydraulic pressure as per the consumption, as per the drop in the hydraulic pressure. Okay. So if any reason, let's say you increase the RPM, you decrease the RPM, whatever you have done, the first there is variation in the pump pressure. It's the controlling pump which will fulfill that increase in demand or decrease in demand. All right. And then follow pump will increase or decrease their capacity, and controlling pump will come back to 50%. All right. If for any reason, if the control mode of the selected pump become abnormal, let's say after through pump, number 2 pump was controlling pump, and its control mode has, for some reason, has failed. One of the another pump, 1 or 3, not 4 and 5, which is controlled by ECU, not them. 1 and 3 will become control pump. Automatically. Other will become, of course, follow pump. All right. So if there is a case of, in case there is a failure of an MPC controlling its respective hydraulic pump, what are the limitation and how does the control failure affect the hydraulic pump? So different stages of output of the hydraulic pump. Effectively, all engine-driven pumps will have no output when the engine is stopped. Of course, because swash plate is at 0 angle or horizontal. Even when swash plate is at some angle, since pump is not running, that is also true. Pump is not running. HCU controlling pump 1, 2, and 3 will have output up to 100% capacity of their design capacity, of course, whether engine is running in ahead or direction or stand direction. Swash plate can move from 10 to 100% position for pump 1, 2, and 3. Okay. Number 4 video. Number 4 video begins. However, ECU A and ECU B control pump, driven pump, by default can deliver only up to 85% of their maximum design capacity. No more. We say 100%, but actually it's 85% capacity, whether in ahead or stern direction. Actually, yes, in ahead or in stern. Because swash plate angle will be changed by the ECU. It means that swash plate cannot move to 100%, but is strictly only to 85%. This is done by mechanical achievement. Mechanical stopper is there. So it cannot go to 100%. So how the limitation of the capacity is achieved? Of course, control the swash plate angle. So you're controlling the capacity. There is another thing with pump controlled by the ECU. That is, if the pump control fails, ECU pump control fails, these pump will continue to run in this one direction as if by default they will move to the direction when the engine was ahead. That means when the engine was running, so let's say engine is running ahead, switch plate will have certain angle so that suction port, discharge port meets with all other pumps. Now the direction of rotation has changed, it's turned, but pump control has failed. Switch plate will remain in the direction as if the engine was ahead. So in this case, a pump will be pumping maximum its capacity as if engine is in ahead direction. But since engine is in stern direction, ports will reverse because angle of the switch plate is not being changed. That is the thing. So your pressure will drop. There is a possibility if more than, let's say both the pump fail, ECU A and B. Very rare but possible. Both have failed. And you are in the stun and stun RPM required, full stun. Both the pump are running in the right direction, as if engine is in the right direction. So ports have reversed. So other three pumps, which are controlled by 1, 2, 3 ACUs, no matter how, even if they are at maximum capacity, it's possible the pressure will drop. So only way thing is you have to do is reduce RPM. Very unfortunate, very rare situation, you know? But just know that this is a scenario. If something goes wrong like that, this is what will happen. It's for your information only. Okay.